Why don't we just go ahead and start this thing out with Lorene?
I know that was me.
What's your last name? Davis. Lorene Davis, ladies and gentlemen. Big round of applause.
Well, I built this when I was 12, and I was inspired by the Make magazine, actually. I saw a lot of people making this robot. It was open source, designed by Gail Langervin, who's French. And I saw like a bunch of projects around the world building this robot, and it was beautiful. I loved it. And so I built my own when I had the chance. And yeah. So it tells jokes, and
Are they funny?
we've heard them over and over again so many times. I don't think it ever gets old. I love it.
What are you going to do next?
Ha, ha, ha. Was that funny? What was the robot's favorite nursery rhyme? Row, row, row your boat gently down the stream. I know that was so silly. Hi there. What is your name? I am in mood. Do you want to hear a joke?
Yes.
Why can't pirates play cards?
Why not?
Because they're sitting on the deck.
That's a good one.
Ha ha ha, did you get it? Why did boy throw the clock out the window?
See time fly.
To see time fly.
Oh, we got a winner.
Ha 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 ha.
Yeah. And yeah, I've been working on another one. Hopefully, because this one I didn't put together very well, and so I'm hoping to.
He's standing right. He's right there.
Yeah. Sorry. But I hope to make it more functional. Maybe do
Not really standing.
more variety of things. I wanted to experiment with what it could do because it has a lot of capability to do more than just tell jokes, and I wanted to see
Ha
that.
ha ha.
So how would you enhance it? How would you make it better?
Well, I wanted to finish the arms because I didn't have a chance to. I didn't finish the arms, and I want to work on the side motors, and I also want to work on the neck. Along with this motor, there's going to be 2 side motors, so I can tilt its head this way.
Very nice.
Let's see what I can do with that.
Very nice. Okay, so this is the Run What You Brung segment. Who's next? We'll just leave him up there, if that's okay. Who's next? Matt? Is this yours?
The biped is mine.
Yeah.
It's not ready yet, but
Well, come tell us about it.
all right.
Everyone. I actually just met. Hey, Chris. Yeah. Let's just talk about bipeds.
Okay.
I'm curious because I haven't seen the biped in a while. We just met tonight, so it's like looks like we're the 2 people who brought biped robots tonight, and we're both having issues. The funny thing about biped robots is that a lot of inverse kinematics, a lot of forward kinematics, and you can start thinking about. You think, oh, it's just classic science fiction. Let's just build a walking robot, and then you start thinking about all the complexity from like the motor controllers to like the accelerometers and gyroscopes.
Yeah, so I had brought one last month, and then I decided I wanted to do the challenge with it. So the one last month is just like a puppet. You just go through motions, no brain. So then I thought, oh, I need to add a brain. And so, of course, I started, and I just built a whole new one from scratch instead of adding a brain to the old one. Because that's how we are.
Mine's actually based off of a Japanese robot called Plen. The reason why I wanted to build this robot is because I'm very interested in personal robotics. So I started looking at different kinds of open source robot designs I could get, and everything here was 3D printed for my machine. I had to calibrate everything. It didn't exactly work because it's not. They open source a lot of the parts, but they don't design it for 3D printing. So I have to. I ended up laser cutting a lot of the circle horns online. The only thing that's, and then I had to source a lot of the motors and everything. 17 degrees of freedom is challenging, especially when you're trying to get to move around. I think I love the design of yours, by the way, especially if you made it.
Yeah. Yeah.
Yeah.
Just cut out on a bandsaw.
Yeah. It's beautiful. It's absolutely beautiful.
A little rough, but what was I saying? So I couldn't really figure out the 17 and the ankles, because the ankles like really like 2 degrees of freedom, and it was always really hard to figure out how to join them. So I just started out with 1 degree of freedom here and then 1 in the hips.
Yeah, I see you have a few servo points here. Are you using?
Yeah.
Are you using an accelerometer?
No, it's just all still open loop.
Oh. How do you? So does it calibrate for balance, or? Is
No, it's all statically balanced. So
Oh,
it's like
I
Tai
see.
Chi walking.
Yeah.
So it's always
Just kind of
always
just
in
more-
balance.
nice.
Big feet.
Yeah. I think we're both using nickel metal hydrate batteries.
Yeah. Yeah.
Both 6 volts. If anyone has any suggestions, I'll show you what happens when I'm supposed to plug it when I power it on. Right now the servos are powered on, but if I do this, if I turn on the servos, everything slams into place, and unfortunately, it's too much of a current draw on the nickel metal hydrate battery. So all the servos tend to move in a very erratic, random fashion. Yeah, so we're trying to figure out how to, like that, like that. I don't want to keep doing that, but trying to figure out. So, yeah. I think we're just gonna have to switch batteries, but I'm hopeful that we'll talk.
Cool.
Thank you very much. Matt and Chris. This is one of the top Robo Magellan robots in the world, and Marco's going to tell us a little about him. You got him okay? How many gold medals have you won in Robo Magellan? Too many to count?
No, I think 3 something.
Yeah.
So 2 at Robo Games, and unfortunately they ended.
Go to the other table. Put it on the other table over there. Let's go to the other table there. Do whatever you want to do.
The motors are disabled now, so it will not jump off the table. Yes, so that's pretty successful, except for today. It was basically used as a display piece 2 weeks ago for the class of my wife, so to show what you can actually do with little almost Raspberry Pi and some Arduinos and some pieces. And if you have seen me at Maker Fair or some other places, I usually have a big zoo of robots from little Arduino maze things to this guy and Mars rover. And yeah, kids usually seem to be interested, and yeah, I build them, I can show them, and most of them actually can be driven by kids. That one not so much, because it can take out a 5th grader very easily. So it's running Pixark, Autopilot, and Odroid U3.
Pixhawk is cool. They use it in drones usually, get the satellites. When Marco won the Robo Magellan last year, shortly thereafter, he publishes a map of the route that he took.
Yeah, so the Pixar as autopilot is used as basically for drones, for model planes, rovers, and even submarines by now. And basically open source software adapted to whatever is needed, and they have a nice ground control station with it, and so you can really see what's going on. ROS, most people know by now, is very helpful. You get a lot of libraries and can basically stick together whatever you need. It's running here, basically Vision, OpenCV to find the cones, and it was running Move It on the ARM to basically calculate the trajectories for the different servers. So yeah, that's about it.
Dr. Alan Fetterman, ladies and gentlemen. How many other robots do we have for show and tell? Raise a hand, please. Come on, folks, don't hold out now.
So unfortunately, today I brought what I can't run because I can't connect to the Wi-Fi. And I think it's because there's just so much Wi-Fi here. The Raspberry Pi is not showing up. But what I can do is explain what I have. Oh, microphone.
This blue one here, dude.
Hello? Okay.
That one's even better.
That one works. Okay. So this is the pretty much standard SV-ROS bot-back package, enhanced by the use of the Raspberry Pi
Ralph
camera.
Knock, ladies and gentlemen. Where are you,
So
Ralph?
Ralph-
Stand up. There he is.
Worked on that a lot. And please come to the SIG, which is also co-sponsored with SV-ROS, because we need a couple little things added. So for example, and Mike Ferguson worked on this a lot, we already have the bump sensors, but so far nobody's integrated that into our obstacle avoidance.
That was Mike Wimble made the bump.
Yeah, we still have that, and that's added into the repository. We also, the NITO has intensity on the LDS. They use that, NITO does, to back up into its charging station. So you actually can, that data is actually being broadcast in messages, except none of our scripts so far has actually been utilized to use that intensity, and that could be used for locating objects that are bright. So if you put retroreflective tape around an object, it would see it. The Raspberry Pi camera is also useful for navigation. So using the Ubiquity stack, we can get markers like this, and we can view those. Those are used for making maps. Unfortunately, right now, we don't have any way, or no one has taken the time to integrate the maps made by this with the LDS, the LiDAR map. So
Can you hold that
that
up
needs
again?
some code. Yeah. So this is a marker. So the other thing that's been added to this is a real-time clock. I don't know if this will be. It's a real-time clock, which probably hasn't been reset in around 5 years, so it's probably not very accurate. But that's all useful. So one of the things I was thinking about is in future versions of the Floorbot Challenge, doing a Robo Magellan, and I think I have some sample cones. So maybe have this, and maybe have a Table Bot Challenge Phase 5. navigate around cones on the tabletop. So I think that's really feasible now because the Raspberry Pi camera is a $10 camera, and you certainly can do color blob tracking and things like that. So we need coders. We need people to enhance the code so we can do more cool stuff. That's it. Thank you.
In 1982, I picked up a book, How to Build Your Own Self-Programming Robot, wherein David Heischerman explains the 8085 microprocessor control device. You program in binary, 8 data bits, 12 address bits. You load it 1 byte at a time. I spent about 5 years on this. I eventually made, and the cool thing about it is that it was electronics, it was mechanics, and it had a bit in it about something called machine learning. And in it, David Heischerman specifies 3 levels of machine intelligence. First is random, which can hardly be called intelligence, but it's just making random motions. The second is memory, so that when the robot reacts to a stall pattern and the reaction is successful, it remembers that. So the next time it's in that motion pattern, it tries the successful response. If it continues to be successful, it increments the confidence level. If it's no longer successful, it decrements its confidence level. So the second level of machine learning has an element of memory to it. Finally, the third level is generalization, where when the robot encounters a stall condition for which it has no high confidence level responses, it tries other high confidence level responses before reverting back to random motion. So if you look at a differential drive system, there are 9 possible motion codes, including 0 if you want to call that a motion code, okay? But the only 2 motion codes with any magnitude or displacement are forward and reverse. Otherwise, the robot just spins around its axis. So I've taken this 8085 microprocessor control device that you program 1 bit at a time in binary, and I put it into an Arduino. And I use the Roomba mobility sensor. I prefer to call it a stall sensor. I have a little emitter detector here, and the robot will basically first do random motions, trying to keep this little wheel moving. And the only motion pattern which keeps the little wheel moving is either forward or reverse. So in alpha, it'll try different motion patterns. Then finally, when it gets a successful response, you see it go back, and the net result is the robot goes back and forth. It's not that the robot goes back and forth, it's that it learns to go back and forth. So without any further ado, I give you Rodney Jr., the machine learning robot. Oh, nice. Thank you, Jordan. Yeah, that's about as good as we do. So here he's just trying random patterns. And when the LED, these are thinking LEDs, is red, it's stalled. When it's green, it's moving, okay? So from one motion pattern, he's gotten forward there. I get 3 tries at this. Okay, let's try number 1. It still looks confused. I thought he was going to figure it out that time. Well, this is a tough night all the way around. Okay, I'm going to give it one more try, and that's it. Boy, this is
Have you run it in
rough.
the box before?
Pardon?
Have you run it in that box before?
You know, I had, and 2 out of 3 times it was successful this morning. Believe me.
Stalling against the sides is skewing the deck.
Yeah, okay, I'll go with that. It's pretty crude. He should be able to figure it out anyways. I think he has it. Yes. Thank you. The robot is going backwards and forwards. It's not that the robot's going backwards and forwards, it's that the robot learned to go backwards and forwards. Thank you very much.